By the way, the homework that I recommend that you do, especially those of you going on to Cal 2, which is almost everyone. Who's not going on to Cal 2? This is it. Last. Okay, so, all right, just Cal. You don't need Cal 2 at all? No? No? Okay, so for those of you who are going on to Cal 2, I would highly recommend that you do all these problems and then you do them a week before the semester starts. For Cal 2, you do them again. All right, you do not want to walk into Cal 2 cold. Enjoy your break, but don't walk into Cal 2 cold. I was trying to think of an analogy that I could use, and the best I could come up with without being too morbid was if you've ever been to the beach and stood in the waves when the waves are coming and crashing on you. I mean, I know we don't have big waves on our beaches here in Texas, but if you try and just stand there and take a wave, right, it's going to knock you down. You have to, if you want to like be able to stay out there, you have to kind of like go with the wave a little bit, right? Give a little bit, be running as it's coming. That's kind of like Cal 2. Cal 2 is coming. It's a big wave. And you do not want to be standing there. You want to be running so that it'll just kind of pick you up and you go with it. If not, you're going to just get run over by it. You dive under, and then the rest of the class is over there, and then you're back there, and you're going to wait for the next semester where the next wave comes. Oh, okay. That's a pretty good analogy. I like that analogy, right? I mean, that's the way it is. It is seriously. I've already told you, I'm not trying to scare people, but you just have to be ready for it. It is going to just come at you, and if you're not ready to like step up your level, then you just will just get washed away. It's the speed of the material. It's the rate at which it's coming and the difficulty. It's both. So yeah. Most people that are, like get through the Cal 2, they're like, Cal 1 was so much easier than this, you know, like it was. But it's also exciting. It's fun. You start to really use your head in a way that you haven't before. Cal 3 is not necessarily harder. By the time you get to Cal 3, you've kind of like, you know now. Yeah. Yeah, pretty much. Cal 3 is actually just where you get to explore. It's more exciting. I like Cal 3 because it's not that. It's not like, oh my gosh, I have to learn all of this in like this amount of time. It's just like, oh, that's cool. You can do that and this and that. And we use limits. We use integration and differentiation in Cal 3. It's all kind of together. So it's cool. Oh, limit's never going away. I told you that in the beginning, remember? Limit, everything comes off the limit. All right, substitution. The goal here is to add something to our toolbox that will allow us to handle more integrals, because right now we can only handle x to powers, and it's got to come off that formula sheet where it's like I said, antiderivative cosine or something like that. So is there something we can use that will help us? And the substitution is our first real attempt at trying to do some more complicated problems. So what I'm going to do is I'm going to give you an integral, and for this first one, we'll just do that. And I'm going to tell you for this problem, I'm going to do what the book does for some of these. I'm going to tell you the critical part of the problem, which is what the substitution needs to be. The substitution you need to make is u is equal to 3 plus x to the 4th power. Do y'all remember the steps that I told you for substitution? I'll put them up here, but I'm not going to erase the board, so it's going to look weird. So what we want to do is we want to look at the integrand. The integrand is all this stuff in here. Try to find, quote, something and its derivative. So you want to visually look in there and see if you can see something, and separated from that, its derivative. The derivative that you see should appear in the numerator. The derivative might be off by a constant. Once you find that thing, that something, let it be u, and then go for it. All right? Those are the steps for substitution. There's nothing more to it. So when I look at this, I'm already telling you what the substitution is, but let's see why it's the substitution. When you look at this, do you see something in its derivative? What's the derivative of x to the fourth? 4x cubed, right? Do you see it? There's 4x cubed, isn't it? 4x cubed is a derivative of that. But why is this the substitution instead of 4x cubed? What's the derivative of this? Still 4x cubed, right? It's the same derivative. So when I'm looking at this, I'm trying to find something in its derivative. So hey, here's something in its derivative. Good, I found something. Now let me try and grab a little bit more. So I grab a little bit more. How about let me grab the plus 3 also. Is that going to change what the derivative is? Derivative of that is still this, right? So let me try and grab more. To grab more, I'd have to grab the parentheses and the 90th power. What if I try that? What's the derivative of this? 90, this to the what? 89. Do you see that in here? Do you see 98, that to the 89? You don't see that in there, right? So this is actually too much. You grab too much here. And x to the fourth, you didn't quite grab as much as you should have, because this is more efficient. You're gonna include the 3 in your substitution. Do y'all see why those two are not good candidates for you? Sure?
So it's telling you what you should substitute for.
Yes. This right here, this expression, I'm going to replace that entire expression in this problem with u. But there's a bunch of other stuff that's still out here, right? Okay, so once you have your substitution, once you actually find this, then what you do is you take the derivative of u, of both sides with respect to x. So du dx, Leibniz notation, and then we just said the derivative of this with respect to x is 4x cubed, right? And then the next step is something that you will always do, and that's isolate the du by basically multiplying both sides by the differential dx. So it's like you're doing dx here, cancels, then dx here. So you're going to get 4x cubed dx. Still got it? Sure? All right, let's kind of recap what I've got so far. I've got 3 plus x to the fourth right here. That's going to be replaced with u, right? So that's going to really look like u to the 90th power. And then I have this 4x cubed, and this is multiplication, and this is multiplication, dx. So I could slide that right back here with this, right? And put 4x cubed dx. And that's this, exactly. So I'm going to replace everything in blue with what? du. And now I'm going to rewrite the problem. So this becomes integral. Let's start with the red stuff. The red stuff is going to be what? U to the 90th power. Times this and this together was du, and it doesn't matter if I put the du in front or the du in back, but we normally put it in the back. So times du. And now we're there, because if I asked you to just completely forget all of this ever happened, and I walked in here and just asked you what's the antiderivative of x to the 90th, you would say 1 over 91 x to the 91, right? But this is u to the 90th with respect to u. So the answer should be 1 over 91 u to the 91. Yeah? What? Plus c. You follow how that worked? Ask the questions. This is the time.
Okay. Because we're working back.
We're working back, yeah, antiderivative, right?
And so the reason you could do du of dx is because you created the variable
I created this equation, right? I just came in here and said, hey, look, everyone, I'm going to just call this u. I'm allowed to do that. I can call that whatever I want. I could have called it p. It doesn't matter. And if I create an equation, then I can differentiate it with respect to x or u. It's up to me. I did x. The reason I did that is because I know this is going to happen. I know I'm going to get the dx out. I know I'm going to start playing this matching game. And I even knew that this was going to appear over there. Why did I know that that was going to appear over there? Because that's how I chose u. I chose u so that it's, remember what was the condition? Find something and its derivative. So I knew the derivative of this was going to be there for me to match with.
Can you explain? So I'm just having trouble seeing why the du goes away.
Well, it's the same reason that it went away when we were doing like x squared dx. This was just notation, right? I said this part tells you to find the antiderivative of x squared. This was telling you with respect to x. We changed the whole problem from x's to u's, and when you do that, this dx no longer is 1. That dx is actually connected to du. So du is not just 1, it's actually this. I know it's confusing, but...
So you don't substitute back?
Oh, no, I'm not done.
Oh, okay.
Yeah, I just want to make sure everyone was good up to that step, right? We're good there?
Because this one, so du t, I mean, it's kind of like f prime, right? That means
This right here?
Yeah.
Yes.
Okay. So when you take the antiderivative of that, so it's going back, that would be like going back to...
You're not doing the antiderivative of this.
I'm just having a hard time seeing that.
Okay, so you're very comfortable with the chain rule, right? So let's say I said this. Take the derivative of u to the 4th power. Take the derivative with respect to u. You would say 4u, right, times the derivative of u, du whatever, right? If it's with respect to u, we would say du, right? But basically the derivative of u is here. It's a 1 usually. But in this case, it's not a 1. So now if I ask you, hey, look, integrate this, where are you going to go back to? U to the 4th, right? So it looks like this goes away, but it's just because the chain rule, it was sitting out there. I hope that that makes sense.
Yeah, that makes sense.
Okay. So what is our final result here? 1 over 91. What was u? I erased it. 3 plus x to the 4th to the 91st power plus c. So that's my final answer. I replaced the u back with 3 plus x to the 4th. Now, can we check the answer? Yeah, take the derivative of this. So what would happen? Chain rule. 91 comes out, 91's gone, right? This whole thing to what power? 90th, right? Times the derivative of what's inside, which would be 4x cubed. And that's exactly what this is, right? That's exactly what that is. Yeah. Substitution is a game. You're trying to play a game. You're trying to find something in its derivative, then you're going after it. And it doesn't always work. Yes?
So Cal 2 is the solvent.
The what?
The solvent.
Some, yeah. Okay, yeah.
Sorry,
No.
I missed that last step. So where does the 4x3 come back in?
I was just checking our work.
Oh, okay. Oh, because
If I take the derivative of this, I should get back that, right?
Yeah, I see. Thank you.
Okay, so look, the other homework I suggest you do is this page 306, numbers 1 through 6. Every one of those problems, they give you an integral, and they tell you what u is, and they ask you to try and work it out. All right? So I recommend you do those, 1 through 6. And if you really feel brave, like if you kind of understand it, the substitution idea, there's problems 7 through 52. Problems 7 through 52 after this. That's basically the homework assignment for my Cal 2 class, is to do all those. All those are on video, by the way. The solutions to those are all on video. It's under my Cal 2 class. Huh?
7 to 52 is all of Cal 2.
So we could do that and get ahead of our homework.
Well, that section, yeah, that in Cal 2, we will do section 5.5, which is that homework assignment right here. But the first 6, they tell you what U is. After that, they stop telling you what U is. And you have to figure out what U is. Yeah.
I think I'm taking your more than Cal 2.
Okay. All right, I guess that's it. Thursday will be our last day, and we'll do a little more of this and evaluation theorem. We'll talk about the final.